So we have rain on the roof of this building falling at 0.1 inch per hour at a terminal velocity of 8 meters per second. What's the average force being exerted on this roof? They're going to have to make some reasonable estimates. You know, how big is the roof? Right? Okay, so I ask you, okay, list some principles. Give me some principles. See which ones are relevant. Go down through your whole list of principles and ask what the relevance is. First one was, okay, change of potential energy is equal and opposite to the work done by the net force, right? Okay?
Is the impulse momentum theorem relevant?
Yeah. Yeah. And of course, since that's the most recent one, okay, so we'll come back to that, but since we had an interesting discussion on the irrelevant part, it's worth reinforcing, especially since none of you all have taken your test yet, okay? And this could be relevant in principle. It's irrelevant. Why is it irrelevant? Well, I haven't said what is irrelevant. I've said it, I haven't written it. But it's irrelevant since okay, change of potential energy is equal and opposite to the work done by conservative forces, right?
Yeah.
So, if say the rain falls from 1,000 meters, okay, then we can compare change in potential energy with change in kinetic energy to find work done by non-conservative forces, right? And you know what the relationship is there, so I'm not going to go any further with that, but we could, and I'm probably going to go ahead and calculate a potential energy change, okay? Because right now we got a major hurricane hitting the panhandle, Florida panhandle, right? And we're fairly likely to get at least some rain peripherally as it passes through the Carolinas, but it's a biggie, you know, it was a Category 4, which nobody's expected to go beyond Category 3. All of a sudden it was a Category 4. Now, you know, it's really nailing a large swath of the Florida coast, panhandle, and nearby. And energy is real important to a hurricane. Why did it pick up all that energy? Because the water in the Gulf is really warm, and that's where it gets its energy from. So we had a tropical storm a couple of days ago that might become a hurricane, then it might become a Category 2, then it might become a Category 3, and all of a sudden we got us a Category 4. Okay? So the energy relationships, potential energy, and the thermodynamics of it are interesting, so we'll probably talk about it since it's a current event and very relevant. Okay? I mean, very relevant to the stuff you need to know for the test and beyond. Okay, well, then we can compare. Okay, well, let's go back to this because we had a suggestion for impulse momentum. So how are we going to apply impulse momentum? And incidentally, where does impulse momentum theorem come from? What principles give us the impulse momentum theorem? Principles, definitions, and so forth. Definition of velocity and acceleration give us the equations of uniformly accelerated motion, okay? Now this applies whether motion is uniformly accelerated or not, okay? But for uniformly accelerated motion, which is what I expect you to be able to derive, we just take one of the equations of uniformly accelerated motion, plug the expression for acceleration from Newton's second law in, rearrange it in about 2 simple steps, and we have the impulse momentum theorem, okay? Average force, or the force for uniform acceleration times delta t is a change in the quantity mv, and the quantity mv is momentum. You need to know that because you're going to have big assignment momentum for next week, okay? That's where the whole thing starts, which is, of course, why we're doing this, okay? So you need to know that. But let's go ahead and, if you write down impulse momentum theorem and don't immediately think, okay, definitions, equation of motion, Newton's second law, yeah, duh, okay? There are only less than 10 things that you need to know to be able to do this whole course, okay? Less than 10 things you need to know how to work out from the basic principles, and you don't need a formula sheet, you don't need to go to the internet, you just need to be able to navigate it. Of course, it takes practice with problems, and you want to always think back to where this comes from the basic principles, because then it might stick with you as opposed to equations that you memorize for a test and forget a week later, okay? That won't stick with you. I mean, if you've got photographic memory, maybe, okay? But if you're not using them, they'll get away from you. Go back to principles. Okay.